The binomial expansion of 1 minus x whole raised to the power minus 3 can be written as t1 plus t2 plus t3 plus and so on plus tr plus and so on to infinity, where the rth term tr is equal to minus 3 multiplied by minus 4 multiplied by minus 5 and so on till minus 3 minus in brackets r minus 2 divided by r minus 1 factorial multiplied by minus x whole raised to the power r minus 1. This is equal to minus 3 times minus 4 and so on till minus r minus 1 divided by r minus 1 factorial multiplied by minus raised to the power r minus 1 multiplied by x raised to the power r minus 1. This is equal to minus raised to the power r minus 1 times, in brackets, 3 times 4 times 5 and so on till r plus 1 divided by r minus 1 factorial multiplied by minus raised to the power r minus 1 times x raised to the power r minus 1. The product of the two terms, minus raised to the power r minus 1, is equal to 1, and multiplying and dividing by 1 times 2, tr is equal to r plus 1 factorial divided by 2 times r minus 1 factorial multiplied by x raised to the power r minus 1. And this can be written as 1 times 2 times 3 and so on till r minus 1 multiplied by r plus 1 divided by 2 times, in brackets, 1 times 2 times 3 and so on till r minus 1 multiplied by x raised to the power r minus 1. 1 times 2 times 3 and so on till r minus 1 cancels across the numerator and the denominator, and therefore the value of tr simplifies to half of r times r plus 1 times x raised to the power r minus 1. Now recall that the sum of the first r natural numbers is equal to r times r plus 1 upon 2, and if we denote the left hand side by SR, then SR is equal to r times r plus 1 upon 2. Now 1 minus x whole raised to the power minus 3 is equal to t1 plus t2 plus and so on plus tr plus and so on, where tr is equal to half of r times r plus 1 times x raised to the power r minus 1, which using the result above is equal to SR times x raised to the power r minus 1. And therefore 1 minus x whole raised to the power minus 3 can be written as S1 times x raised to the power 0 plus S2 times x raised to the power 1 plus S3 times x square plus and so on plus SR times x raised to the power r minus 1 plus and so on, which is equal to S1 plus S2x plus S3x square plus and so on plus SR times x raised to the power r minus 1 plus and so on. And this is the required result.